sun has set, and moving across the sky during the day, it has left its imprint on the magnetic records of several observatories. Alibag near Bombay is unique among them. Can you visualize the consequences of the lethal radiations from outer space if the protective shield of the Earth's magnetic field is totally withdrawn? Can the science of geomagnetism be harnessed in the service of mankind? These and other questions are answered by the story of the Indian Institute of Geomagnetism, IIG. Indian Geomagnetism, 150 glorious years. Ancient Indians certainly knew about the attractive property of iron. The magnetic compass is an inexpensive but vital tool even today on board aircrafts. Geomagnetism is enshrined in the waves over the oceans, the summits of the mountains, the fields that we traverse and what lies beneath, the blue skies and the invisible atmosphere. As a science, it deals with the changes in the strength and direction of the Earth's magnetic field at different points in space. Observations from the Indian subcontinent, with its proximity to the equator and extensive landmass, has played a crucial role in the development of the science for over a century and a half. Geomagnetic field measurements commenced at Colaba Observatory, Bombay, in 1841. Pioneering research efforts and outstanding scientific discoveries have emerged from these modest portals. Electronics and technology have taken this field from the mere intellectual exercise of the early 20th century to one with applications in exploration for natural resources, groundwater, earthquake prediction, weather modification, and health. Distances too have shrunk, and magnetic measurements by the Indian team are now carried out round the year, even in the icy continent of Antarctica. Indian geophysical stations Dakshin Gangotri and Maitri are now on the global map. Indian magnetic data are regularly distributed worldwide. Their analysis and interpretation have been instrumental in firmly establishing the elusive links between the Sun, the interplanetary space, the surface magnetic field, and the Earth's interior. The genesis of geomagnetism as a science is credited to William Gilbert, who was the royal physician to Queen Elizabeth I. He postulated that Magnus magnis ipse est globus terrestris. The Earth globe itself is a great magnet. An astronomical observatory was already functioning in Bombay since 1823 at Colaba, off the Gateway of India. Regular magnetic measurements began here in 1841 and continued for the next 65 years. The hemispherical copper dome and the special non-magnetic structures with a quaint old world charm stands out as a distinct landmark in South Bombay. Eminent scientists have graced the director's chair here. Fellows of the Royal Society of London, illustrious students of Sir C.V. Raman and others. Foremost among them is the first Indian director, Nanabhai Moose. His painstaking analysis of 60 years of Colaba magnetic data led to fundamental discoveries on the characteristics of the geomagnetic field. In the early 1900s, when the proposal to introduce electric tramways close to the Colaba Observatory was being considered, Nana Bhai Moose had the foresight to find an acceptable alternative at Alibag. The choice was impeccable, as comparative observations over 2 years proved decisively. An ideal magnetic observatory with no artificial source of disturbance in its vicinity came up at Alibag in 1904. Together, Colaba and Alibag have given 150 years of uninterrupted geomagnetic measurements to Indian scientists and to the world. A unique feat indeed. Let's see how this internationally reputed standard magnetic observatory carries out its functions. Classical instruments dating back to the mid-19th century are still used, if only to show their intrinsic quality and reliability. With changing times, more sophisticated instruments using electronic chips have taken over. They provide accurate observational data at the turn of a knob or the press of a button. It is a matter of pride that these are made by IIG itself, a significant step in import substitution. The magnetic field continuously changes from one instant to the other. For the initial 30 years, these were visually recorded every hour throughout the year. Introduced in 1872, photographic registration offered relief from this tedium. Over the years, this too has seen significant modifications. The devices are housed in a special non-magnetic structure constructed for perfect thermal insulation, maintaining the room temperature to within 1 degree during the day without electrical or air conditioning accessories. Thanks to technological developments, the modern sensors are compact, stable, and extremely sensitive. Neither temperature nor humidity affects them any longer. Instrumental sophistication has also enabled direct digital recording with microprocessors. We can now get real-time information of the magnetic state in any part of the world. Today, the Institute of Geomagnetism has under its umbrella a network of 8 magnetic observatories. High-quality magnetic records from these locations are received and analyzed at the Central Processing Unit of IIG at Bombay. The magnetic records are the manifestations of subtle changes. Like fingerprints, 2 charts are never the same. They are scrutinized and processed to provide data to the scientists everywhere through a network of world data centers. The center based at the Institute caters to the needs of the Asian region. The year 1971 was an important milestone. The Indian Institute of Geomagnetism was born, carved out of the Indian Meteorological Department. Today, it functions as a premier research center of the Department of Science and Technology of the Government of India. Observatories for data acquisition and dissemination. Upper atmospheric physics dealing with space far and near. Solid earth geophysics dealing with the terra firma are the major areas. Solid earth conjures up visions of one homogeneous sphere of the planet Earth. But studies of earthquakes suggest otherwise. A solid upper crust, a molten mantle, and a liquid core deeper down. The hidden secrets beneath could be prized out through surface geomagnetic measurements using state-of-the-art technology. Prominent among them is the magnetovariational method. Specially designed magnetometers are buried and geomagnetic field variations are registered in a closed network for a few months. The retrieved data are analyzed based on Michael Faraday's axiomatic discovery that a fluctuating magnetic field induces currents in an electrically conducting body. As the geomagnetic field oscillates faster and faster, the induction effects are felt closer and closer to the surface. These inexpensive surveys give us a glimpse of the electrical conductivity distribution and the thermal state beneath the crust to depths down to 1,000 kilometers. From these studies, we understand the tectonic framework of the Indian Shield and the Himalayan collision zone much better now. Improved depth resolutions are obtained when electrical parameters are also measured along with the magnetic field. This technique is popularly known as magnetotellurics. Crustal structures to depths of the first few tens of kilometers determined in this fashion are useful indicators of natural resources. Using the higher frequency bands of the natural or induced oscillations, we probe still closer to the surface. This enables us to locate oil-bearing sediments, groundwater, or minerals. If only we could predict the precise location and onset of an impending earthquake, precious lives and properties would easily be saved. The Department of Science and Technology has organized a major program to monitor changes in several parameters preceding an earth tremor to be used for earthquake prediction. Under this, the Institute of Geomagnetism carries out measurements of electrical resistivity and magnetic field in earthquake-prone areas. This line of investigation, still in its infancy, has, however, a promising future. The Earth's crust adds its own specific contribution to the total magnetic field. To identify individual regions of anomalous crust by ground survey is quite formidable due to inaccessible terrains. However, uniform global coverage from an orbiting satellite of USA became available in 1980. IIG, as a member of the Global Investigation Team, have successfully used the data for interpreting the features in the Indian subcontinent. The ocean floor beneath the blue seas is not one smooth, soft bed, studded as it is by ridges and trenches. To develop a cohesive picture of the subsurface electrical features over the continents, the support of magnetic and electrical data from the ocean beds is vital. IIG is one of the few research centers in the world to carry out these difficult operations successfully in the Arabian Sea and the Bay of Bengal. The majestic mountains not only provide environmental balance to the fragile ecology, but also hide in their bosom the history of the Earth's evolution dating back to several million years. It's amazing that a tiny piece of rock freezes in itself the direction and intensity of the geomagnetic field prevailing during its formation from the molten lava. Paleomagnetism deals with the weak magnetic field of the rock samples. To get at this, the rock samples are removed and carefully heated in a furnace in complete magnetic vacuum to remove interfering impurities. To generate the vacuum, special configurations of coil systems are used. The residual magnetic field after this cleaning is mainly due to the effect of the distant past. It is then measured accurately. Such studies have revealed that the Earth's magnetic field flips in direction every few million years, and India was perhaps once close to the continent of Antarctica. In 1902, Marconi demonstrated that radio waves could be broadcast several thousand kilometers across the Atlantic because the upper atmosphere is electrically charged. And to think that this was predicted almost 2 decades earlier from the smooth daily variations of the geomagnetic field. Dr. Moose, among others, could pinpoint that during periods when the sun gets active, the geomagnetic field is disturbed, leading to magnetic storms. Apart from the sporadic bursts, a stream of ionized gas is continuously ejected from the outer regions of the sun. These are clearly visible during a total solar eclipse. This mass of streaming charged particles, called solar wind, sweeps across the intervening space, interacts with the Earth's magnetic field and confines it to a cavity, the magnetosphere. Within this volume, the Earth's magnetic field is dominant, while outside, the Sun is in charge. The Sun-Earth interplay in geomagnetism encompasses periodic changes of more than a decade to a fraction of a second. India is in a vital zone for these investigations. Physicists at the Institute are engaged in understanding the role of the plasma beams from the Sun and their signatures on the geomagnetic field. Sophisticated experiments at strategic locations record the fine structure of the field oscillations, even as theoreticians ponder over the possible mechanisms of production and propagation of these plasma waves. Geomagnetic storms are known to cause disruption to radio communications. The presence of a disturbed ionosphere in line between a satellite and a ground receiver modulates the signal beamed from the satellite. In other words, the signal scintillates. An inexpensive radio tuned to receive the signal strength can thus monitor the upper atmosphere almost continuously. IIG's scintillation network has been very active in data acquisition. The analysis has helped in identifying the duration of the disturbing patches in the ionosphere. Satellite ground communication and data transmission could be tailored to avoid the durations of disturbances forecast by these studies. Radar signals in specific frequency bands are reflected partially by the atmosphere above 60 kilometers. The received echoes can be utilized to compute wind speeds in the upper atmosphere. These winds are responsible for the systematic smooth geomagnetic variations we see at places like Trivandrum, Alibag, or Ujjain. The partial reflection radar assesses the role of the wind motions in the geomagnetic field fluctuations and the causes for their day-to-day variability. Balloon-borne instruments floating for several hours in the upper atmosphere provide data on electric field and conductivity. These can be coupled to the ground-based information. Apart from its primary mandate of magnetic observatory maintenance and researches in geomagnetism, IIG is also a center whose assistance is often sought by other sister organizations. The Survey of India, in preparing magnetic maps, uses the calibration facilities at the magnetic observatories. The Oil and Natural Gas Commission corrects offshore and onshore magnetic survey data with the help of the records from IIG's network. Magnetic compasses used by the Indian Navy in helicopters or at their base stations, are regularly calibrated by the Institute. So are the magnetic aspect sensors mounted on rockets and satellites of the Indian Space Research Organisation. IIG Bombay is an essential port of call on the itinerary of space physicists and geophysicists the world over. They come here to interact with their counterparts, participate in conferences and seminars organized by IIG. With its excellent library facilities, computers, and team of experts, the Institute offers wonderful research opportunities for the eager new entrant. Bombay University has accorded recognition to the Institute as an academic centre for Masters and PhD degrees. Throughout the past 150 glorious years, the Indian Institute of Geomagnetism has remained in the forefront. A standard yardstick for this is the significant number of original research publications of the Institute scientists in international scientific journals and the membership in international associations. The story of India's contribution to geomagnetism could never really end. The more we learn about the mysteries and myriad features of the magnetic field, the less we seem to know. The sun rises again and ushers in yet another day of challenge to the scientist. The new magnetic records gathered in the Indian network and elsewhere in the world provide new data, raising the hope of coming closer to the ultimate answer to the age-old question: what is geomagnetism?